Hi, this is Dr. Green. We're looking at some examples for the Week 8 problems. So in this chapter, we are looking at survival analysis. And here we have a survival graph. And this was constructed from 7 individuals, and they followed them over a period of 8 months. And they were treated with a drug for prediabetes. And the event described is going to be progression to diabetes. Those individuals who made it 8 months concluded the study without progression. So the first thing they ask us is calculate and interpret the proportion of individuals who progressed to diabetes. So the proportion who progressed are going to be the ones that didn't make it 8 months. So individual 3 and 5, they did not progress, but everyone else did. Individual 1 progressed at 5 months, 2 progressed at 2 months, 6 at 3 months, etc. So there's 2 ways we could look at this. So the proportion of individuals who progressed, so there were 5 out of 7 who progressed, and there were 2 out of 7 who did not progress. Now, I believe in the homework, they ask it one way, but then they state the multiple choice the other way. So we could say that 2 7s, 2 out of 7, which is 0.286, or 28.6% of the individuals did not progress or did not develop diabetes, or 5 7s progressed. So whichever way fits your multiple choice, there's 2 ways to say that. And then for part B, they say calculate and interpret S sub P. So what does S sub B mean? S sub P is the proportion surviving past time P. Okay, so in our example here, P is 8. Okay, so surviving past time 8 means you didn't progress. So in this case, S sub 8 is 28.6% of the individuals did not progress or did not develop diabetes during the study. So that's really an interpretation problem. In problem number 2, we are looking at the Kaplan-Meier approach to estimate survival time. So we've got a clinical study here that's evaluating efficacy of a new drug for prevention of type 2 diabetes, again in people that are pre-diabetic. We had a total of 20 patients. That's going to be the number at risk at time 0. And they were randomized to receive either a new drug or currently available, and then they're followed up for 8 years. And time to progression was noted here. So what we want to do is calculate the survival probability 3 years after diagnosis. So we want that number right here. So you'll be given the time in years, the number at risk at that time, the number of deaths that occurred at each time, and the number censored. So if there's no value, then that means it's 0. So these are zeros even though it's not written. So at time 0, the survival probability, S sub 0, is 1 or 100%. And then to get the next survival probability, you take the previous one and you multiply it by the ratio, take the number at risk minus those who died, or in this case that would be progressed to diabetes, divided by the number at risk. So let's go through these 3 lines here. So at time 1, we had 20 at risk, but then 1 person progressed. Okay, so that means that S sub 1 is going to equal S sub 0, which is a 1, and then we're going to multiply it by number at risk minus progressions divided by number at risk. So 20 minus 1 divided by 20. So this would be 20 minus 1 divided by 20, which is 19 over 20, which is 0.95. So then 1 person progressed, so now at time 2 there's only 19 at risk. Okay, then 2 more people progressed and 1 person was censored, so they were lost to follow-up. So S2 then is going to start at that 0.95, and you do that same pattern again. Number at risk minus progressions, and then divide by number at risk. So in this case then, this will be 19 minus 2 and divide by 19. And then multiply that by the 0.95. So if you do that to 2 decimal places, you will get 0.85. So now we had 19 at risk, 2 progressed, 1 was censored. That's 19 minus 3, so now 16 are at risk, and we had 1 more progress at time 3. So S3, survival probability at time 3 now is going to be that 0.85. And never hurts to carry this out more decimal places. And then this will be, again, number at risk minus progressions, divide by number at risk. So 16 minus 1, divide by 16. So 15 sixteenths. To 3 decimal places, that's 0.797. So this is 0.797, or 79.7%. Can list that either way. So I believe this is a multiple choice question that you answer. So you'll know whether to use decimal or percent. And then this is a survival curve here. So we're considering a survival curve, and along the vertical we've got survival probability from 0 to 1, so 0% to 100, and then time in years from 0 years to 10 years. And we're answering a couple questions here. Number 1, what is the probability of surviving 5.7 years? So we're given time, we want to find probability. So 5.7 years would be about right here. So you go up to the curve and you hit at this level here, which is looks like it's a little bit over 70%, approximately 0.71. So this would be about 0.71. And then the other question, patients have a 40% chance of surviving how many years? So now we're given survival probability, we want to find time. So just do a horizontal line across from the 0.4 until you hit the curve. So from 0.4 we go across, we're going to hit the curve right here. That is going to be at 9 years. So this is 9 years. So you're either given a vertical line, you go up to hit and over, or you're given the time. I'm sorry, that is if you're given the time. You're going to go up to hit the curve and then go over, or you're going to be given the probability, go over till you hit the curve and come down. So one of those 2 possibilities. So I think that should allow you to do all the questions from week 8. I think the rest of the questions are book questions and definitions.